What?
Oh, but somehow you
Like $5,000.
And how many samples do you have?
Well, that's kind of the kicker is we don't want to run it like cheap enough to where we're getting garbage results, but we want to be able to do as many as we possibly can.
And your budget's 5,000?
No, my budget for I'm getting a photo.
Oh, I don't like
What's your budget for?
knowledge and stuff.
Oh,
Knowledge.
no, but one thing. Gotta get that.
So, I mean, hopefully around $30 is what I'm hoping for.
Yeah.
Smart hit me. What are you telling me?
Well, I mean, if it's a certified lab that you want, it's gonna
Yeah, what, 50?
it's multiple analysis.
Jackie, Ioannis just said he hates SOPs.
Sorry, what? Why?
I know. We have an SOP for setting up the computer. Didn't follow it.
We have an SOP for making SOPs.
Well, that's
And I'm
normal.
making stickers that say, did you check the SOP?
Really?
Yeah.
Your students. I went.
What?
Yeah, I'm gonna give one to everybody. And I expect it on just like water bottle. I am making stickers. Yeah. It's like a bubble and it says, did you check the SOP?
I'm gonna put it on every single instrument everywhere in our lab.
Right. That's how you know you're in the penny lab. That
I like
sticker
to
will
say,
be on it.
when in doubt, randomize. I like that one
I
too.
like that one.
That's a good. Where's your sample list? I like.
Wait a couple minutes. Sorry.
I love it.
Yeah.
Scared, my scared
No, the main thing we're looking at is the consumer. So they come with cloud files, and we want to make sure that we can have as many samples as we can. So we'd rather have like more of an overhead if the actual number of times.
They're gonna need help. Yes. So you want to be back?
Everyone online, can someone please confirm in the chat or out loud that you can hear us and see us?
I can hear you and see you.
Thank you. Hi.
Yeah, I'm stuck in
All right, let's go ahead and get started today. Please remember to check yourself in and grab a healthy snack. Right, Kit? We got a request for healthy snacks. We'll work on that. I tried to convince him that Oreos were healthy in moderation. Okay, so welcome to seminar. Today, our speaker is our very own Dr. Ioannis Minas, who is an associate professor of pomology in the Department of Horticulture and Landscape Architecture. He's also the founder of, is that an acronym or a word? What? Excelsior? XLSOR, which is a lab-to-life startup company from CSU Strata. So I specifically asked Dr. Minas to present to us today with an emphasis on that experience and what that process entails of translating your research to an actual product in a company. And so Dr. Minas received his PhD in pomology and post-harvest physiology from Aristotle University of Thessaloniki, Greece. With his roots in a family-owned peach orchard in northern Greece, Dr. Minas has always been interested in production systems and technological advancements that improve grower profitability. He currently performs outreach with the tree fruit industry to guide development and promote adoption of novel systems and technologies to improve general orchard performance and post-harvest handling. During his time at CSU, he has raised more than $2 million to support pomology research. He also serves as an associate editor for, I don't know how to say this one, Scientia Horticultura.
Scientia Horticultura.
Yeah, that. And has authored, what? It's the major horticulture journal, so that really tells you where I'm coming from. It's a serious horticulture journal. He has authored more than 50 peer-reviewed publications in the field of pomology and post-harvest physiology. So please join me in welcoming Dr.
Thank you, Jessica. Thanks for the opportunity. Thanks for joining. So it's gonna be like a little bit of storytelling plus a little bit of field research, ending up developing a product that can be useful for the growers. So, for the ones that know me or the ones that don't know me, I was born and raised in a peach orchard located in this beautiful valley. It was beautiful sometime, in northern Greece. So this is the time of bloom. The entire valley is inked pink because peach blossoms are very beautiful. Old-fashioned cultivars have smaller flowers like these ones that we grow in Colorado, but newer cultivars, they have very showy flowers and they color the entire valley. So lots of people, tourists, are coming just at this time to take pictures and enjoy the peach blossoms. So as I was raising in the orchard, I had the option to continue the farming business, become a peach farmer, but I didn't like peach fuzz too much. So I was getting too itchy. So I decided to become a peach professor. Then, after growing in that valley, I was offered the position to join CSU, located in this other beautiful valley in western Colorado, which is close to the town of Palisade. So peach is following me entirely. So I have very strong grower background, but also I spent a couple of years in that valley, get to know growers very well, understand their problems, their issues, and have a good understanding of the entire fruit industry as a whole. So one major problem that we are seeing in fruit industry is that over 30, and as a society in general, over 30% of the produced fruit do not meet current quality standards that either have been set from retailers, USDA, whatever. Over 50% of the fruit is wasted after harvest. That means about more than 20% of agricultural water is being lost in the wasted fruit. That gives us an estimate of 170 million metric tons of CO2 that is being diffused in our environment. So when I go back to the quality standards, I'm getting irritated when I get grower calls. Can you please, now from California, we're becoming famous, so California growers are reaching out to us. Can you please write us a letter that USDA is declining a load of fruit, like 40 tons of fruit worth $60,000 because of this speckling, skin speckling. So I don't know why this is doing this. So aesthetic appearance of fruit. So USDA has some old-fashioned guidelines that they say if you have more than 50% of the surface of the fruit without golden spots on the fruit, load is rejected. So traditionally, we have been breeding nectarines and peaches based on bricks. So fruit with high bricks content tend to have this speculum. So there is an osmotic problem happening in the fruit lenticels. So high sugar breaks out the cells around the lenticel. You have that golden spotting. So this indicates high sugar fruit. So if you see that in the grocery store, please buy. Don't reject it because they are not fully red colored and they have this golden spot. So quality standards will lose 30%. Another problem that we have in the fruit industry is most of the business of this multi-billion, this multi-billion industry is based on maybe no data. So the growers are making decisions for harvesting by just looking at the fruit. The most experienced growers do that very well. But newer crew people, crew leaders, they don't have so good understanding of ripening situation. In order to do a thorough analysis of the quality and maturity status of the fruit, you need to waste fruit, you need to do destructive analysis that takes time, and you need to have multiple fruit samples. It's impossible a grower that can run a lab like this with a lot of destructive analysis of decision. Some growers do, but they hate it because it takes a lot of time. So no data in the industry. So we're making decisions on when to harvest, when to ship, the distributor, when to expect the fruit based on phone calls and senses. That leads to great losses from harvest timing, post-harvest distribution and retailer, and also post-harvest distribution and retail. So in the harvest, it's a lot is going on with quality standards, shape, some disease that is aesthetically destroying the fruit. But this particular 2 points is just not good management at the pre-harvest level, but also at the post-harvest level. So to make it even more interesting, the crazy weather that we're having right now with the global climate change is creating many shifts in the season for all the seasonal crops. Peaches, plums, cherries, all of these specialty crops they have some genetic background, genetic information on the ripening, but also are affected by the environment. So harvest time is not always exact. For example, this year we had early in the season around 1 week, mid-season around 10 days, late season around a week, later than normal. In an industry that is focused, hey Jeff, good to see you. In an industry that is focusing for a harvest season, harvest window 1 month-ish, 1.5, like 1 week later, is a big deal. So our question is also, can we project harvest time? Old-fashioned approach was tracking weather. That doesn't work. You need to have fruit information, but how you can convince someone to do all this destructive analysis, to collect fruit data about the maturation process, to combine it with weather data, it's almost impossible. So we are also trying to figure this out. So to add more problems on the peach industry is like peach per capita consumption is declining in US constantly over the last 40 years. These are data of the last 10 years. So if you 20 years, 10 years. If you see projections from like 1980, we have the same trend. We haven't managed to switch that. That is driving the production down. This is partially because consumers don't like what we offer. also labor problems. More and more we see less people willing to go work in agriculture, research, and also in actual agriculture. Harvesters, we cannot find labor. So we have a lot of pressure also from that component.
Is that fresh or processed?
This is all fresh. However, still consumers, there is consumers that they are willing to pay premium prices for the fruit they like. So Colorado, even a small industry, is achieving the highest premium price in the nation. So we estimate about $1.2 higher premium price for Colorado peaches compared to the national average. So that's about 15 million is higher value performance. So why consumers don't like peaches and they like all Colorado peaches? So in the past we have done surveys, little flavor, too hard, too soft, never ripens. So you cannot make any sense. They hate peaches. They don't like peaches, but they like Colorado peaches. The reason is old-fashioned say from older growers is like the fruit tastes the best on the time that you pick it from the tree. The more you extend that time, like harvest and consumption, you deteriorate quality. So our current management deteriorates peaches mainly because of this. So the more you store peaches, they develop these ugly symptoms after harvest, during storage, during commercial storage conditions, which are called chilling injury syndrome. You can have all this kind of flesh bleeding, browning, and the most disgusting is mealiness. So the flesh becomes mealy, especially in our own refrigerators at home. So 4 Celsius, 5 Celsius storage, 45 Fahrenheit creates these problems. So in order, as a consumer, to not get your fruit spoiled like that, when you go to farmer's market and you select Colorado peaches, leave them a couple of days on your bench top to start softening and then store them. They won't develop any of these symptoms. So if we fix that, we solve everything. Of course, we will minimize a lot of loss, a lot of problems, a lot of consumer dissatisfaction. But this is something that has to do with preservation of quality. Quality is being built in the orchard. At post-harvest level, we only make sure that we don't deteriorate the quality that we built in the orchard. How we build the quality in the orchard? So 6th graders know that through photosynthesis, we have the leaves, light, CO2, and water. We have the Calvi cycle. We create sugars that go from the sources of carbohydrates, which is leaves. The main sugars are sucrose and sorbitol. They're being translocated to the different seeds, shoots, roots, other leaves, and fruit. And they are being continuously converted to other types of sugars utilized in glycolysis for energy and keeping up with metabolism. So all these components, except of water, is what we call dry matter. So if you have a fruit, you remove all water. It's all the photosynthesis products that have been translocated in this fruit, plus the metabolism that happens in the fruit. We have what we call dry matter. Keep that for later. So we have been spending, since I joined CSU in 2015, we have been spending time to understand which are the most important pre-harvest factors to that affect peach fruit quality. So we have been studying crop load, and I'm going to be sharing with you some of the information that we find, fruit canopy position, and also rootstocks. We have been actively producing review papers on addressing the problems about the peach industry and how we can improve quality. So speaking about quality, these are quality maturation. We use homologies to say quality and we include everything. So these are how the peach is ripening on the tree. Different developmental stages of the fruit from green up to the tree ripe stage. So you see, when we're measuring destructive quality, how many changes are happening to the fruit. For you to become more familiar, California peaches are being harvested at that stage. Colorado growers are trying to be close to here. One other problem that the growers have is the more ripe you get, less storage potential you have. The less ripe you are, you can store the fruit longer. But if you store the fruit for too long, you get chilling injury, you destroy your crop. Timing, harvest timing is very critical for these decisions. So by just seeing the fruit by visual, experienced growers can sense that, but sometimes even experienced people fail. So one truckload, as I said, is about 60,000. So if you fail one day in some of these cultivars, if you go one day later, you may lose 60,000. Tracking quality is very hard, as I explained. I'm a Greek lazy person. I'm like Greek philosopher. I can think what is happening, or can I have a tool that I can use easily and get all the data that I need to know in order to determine the quality of the fruit and harvest time. So since 2016, we have been working with non-destructive sensors, and we are using near reference spectroscopy, an off-the-shelf sensor that is like kind of a prototype, plus our horticultural background to develop robust models. So I'm not gonna explain in detail how we did it because this is like an IP now, but we spend a lot of time, about 4 or 5 good seasons, in order to develop and validate these models. So with one scan, we can measure dry matter content, bricks, and chlorophyll content of the fruit. Why chlorophyll content? Because if you see here, the fruit, when it's maturating, when it's ripening on the tree, it's converting its chloroplasts to chromoplasts. So that's why you have the change of the color from green to yellow-orange. So we are focusing on that background color change to track harvest time. So we did that, very accurate performance. We applied for a patent, and then we started tracking this in multiple Colorado grown cultivars. So with one scan, we can sense dry matter content very accurately, and that's work that was done by Jake Bott. He gave a seminar in spring, very nice seminar, and also chlorophyll content of the fruit. So the question, after we have a good performing device with very good models that can provide accurate data across multiple cultivars, was can we determine in large scale the impact of various harvest factors of incidental quality and maturity, and define links of metabolism with food quality? So I'm going to give you some examples of this crop load, position, and also the impact of rootstock on fruit quality development. So when we talk about crop load, it's like the amount of the fruit that we leave in the tree canopy. So the tree canopy has a certain volume. You cannot change that. You cannot stick leaves on a tree. The practice that the growers do is like they remove a portion of the fruit. So they make sure all these carbohydrates that are coming from the leaves are distributed in higher proportion in the remaining fruit. So you end up with fruit with bigger size and higher carbohydrates content. So in order to sense if our sensor is giving good data, we develop a crop load experiment. We left trees unfilled, and here you can see the distribution of the fruit size. And then we left a little bit less fruit, we thin them on a commercial harvest level. So what growers normally do. And we left 1 fruit per shoot, like extreme low crop load, in order to track the impact. First thing on the fruit size, you see the more we thin, we shift the distribution, always normal distribution. We shift the distribution towards to larger fruit sizes. This is something we know, but we didn't know how well the sensor would work. So the more we thin, we increase the shift the distribution of the fruit to levels of higher dry matter. Okay, and also with the same sensor, we can track its crop load level, its crop load treatment across the season. These are days after full bloom, so we can scan the fruit during growth and development, and we can get a sense of dry matter. So what that tells me is dry matter is being established like 90% early, and then it's kind of stable. If you have high crop load, it declines. So if I can sense somewhere here, then I know my fruit will be good 2 months later, which is really cool. It's an assurance to the grower that can that everything that has happened in the orchard will be okay at harvest. So what is happening with chlorophyll? The more we thin, we advance maturation. Less chlorophyll, more mature. So higher chlorophyll, less mature. So when you are thinning the trees, you are shifting the distribution towards to lower chlorophyll values, which means you are advancing maturation. So harvest will happen earlier. And also we were able to track harvest time on those treatments. So then we had the fine idea, because with one scan we can get dry matter, Briggs content, which I call SEC, and also chlorophyll content. I said that's really cool. Can we track fruit from different crop loads and select fruit that are equal in terms of chlorophyll content, and then bug Zaki and Jessica to see, can we track metabolism of those fruit? So here I'm giving you an example of 2 crop loads. What's happening in the fruit metabolism when you are thinning or not. So we have 2 extreme cases. Here the unthin and the commercial thin. You can see how the fruit volume is increasing in one case and how it's not increasing in the other case. When we put all the quality parameters that we measure at the different developmental stages, we saw that S2, S3, S4, you can see here S2, S3, S4 are the different developmental stages. Green, yellow, green, commercial harvest. The fruit with the closer phenotype are getting closer in the PSA. That's normal. We measure weight, chlorophyll, whatever, firmness. So the phenotype was pretty similar early in development. So right after harvest, like 2 weeks after harvest, we had a very close phenotype that is showing in the PCA. At harvest, we see the separation in terms of phenotype. So thinned versus unthinned is something that we expect. Big and small fruit are completely different. The interesting part was when we did the GCMS analysis with Jack and Jessica, we saw that the biggest difference happened when the phenotype was the same. So immediately after thinning, the carbon competition provided or induced changes in the fruit metabolism. That is very interesting. So later in the season, when the phenotype was the same, the fruit metabolites were looking similar. Partially, this is because we sense primary metabolites mainly with GCMS. So primary metabolism is not affected by pre-harvest treatments that heavily, but early on, the difference in carbon supply on those highly stressed fruit gave a signal, and different metabolites were expressed. So we got excited about that. And we were able to track with LCMS analysis now that phenylalanine, an aromatic amino acid, was affected also. That is related with flavonoid synthesis. And you see catechin was observed also in GCMS data, but we see the same trend. Very early, we saw like in some of these phenylpropanoids, 80-fold difference. So carbon is affecting phenylpropanoid synthesis. Some of these flavonoids you can see here, I'm writing, they're contributing to stress, plant defense. So maybe with more carbon, we have a priming effect, so we have a better phenotype at the end. So this research, I hope we get the full crop one of this current season to continue the research. So we were using the sensor to track how canopy position is affecting fruit quality. So we were scanning the fruit across the canopies of two different cultivars, one that is very vigorous, the other that is very weak and allows the whole sunlight to penetrate the canopy. You can tell from the shade in the bottom. This is super vigorous, doesn't allow too much light in the bottom of the canopy. This allows sunlight. So because we have the capacity to control for maturity, when we scan with the sensor, we can select the data, the fruit, that are equal in terms of maturity. Because as you see, the different developmental stages, the different maturity stages are affecting quality. So if I want to know how a pre-harvest factor is affecting quality, I need to be able to compare equal things. So by tracking chlorophyll, you can see here the weak trees, the trees that have more light. You can see here light availability in the top of the canopy was 97, 21 in the bottom, 68, and 5 in the other tree. So in the more uniform light distribution, we get uniform fruit quality when we are comparing fruit of equal maturity. You can see here the chlorophyll index was 0.7, but dry matter was very similar. Here, chlorophyll index was 105, 108, but dry matter was 2% different. Consumer can sense 1% difference. So with that, gave the message to the growers, you need to make sure you manage your canopies in a uniform way. You do summer pruning in order to allow light to penetrate so you can harvest uniformly. We track also metabolites, the same concept on fruit of equal maturity. We saw that sorbitol, sucrose, and catechin are expressed on fruit with the superior quality. When we have a lot of amino acids and organic acids, it's fruit of low quality. I'm not going to explain all of this now. We did the same thing with rootstocks. So rootstocks are, do you know what rootstocks are? Horticulture graduates? Can someone tell me what is a rootstock? No? Yeah?
It's the base portion that you graft the top scion onto.
So it's a different cultivar, a different species, or a hybrid that we use only for the rhizosphere system. So we graft a favorite scion that we want to grow the fruit. So this allows modern fruit production systems to produce fruit in different pedoclimatic conditions. Okay, but also the rootstock is affecting canopy size. So it can give you a small tree, exactly the same cultivar, versus a very large tree. So we wanted to see the effect of rootstock on, and we are tracking that through NC on 40. This is another project that we're doing. But we have a particular project in 2009 that we have very large trees. With black bar is the trunk cross-sectional area, how big the trunk cross-sectional area is. And you are looking at the rootstocks from Atlas, which is very vigorous, to Prince 1, which is the dwarfing rootstock. The more, the more dwarfing the rootstock is, we saw with scanning intensively that you get higher fruit quality. That means more light in the canopy, less denser canopy, you get higher dry matter content. So we have a reverse, a negative relationship between rootstock vigor and fruit quality at the end. So both of them, all of them were tracked for 2 seasons at equal maturity and equal crop load. So we left a given amount of fruit per square centimeter of trunk cross-sectional area. So that's, and we track also metabolites. Okay, we have a device that's measuring well. I throw you so much information. We inform growers how they can change practices, how to look and understand fruit quality. But now what? So one thing was, I had these models and stuff, and I talked to Dr. Prini. She told me, why you don't make a provisional patent? I didn't know even what a provisional patent is back then. Later on, after the provisional patent, I was reached out from the Lab to Life program, which is a new entity from CSU Strata. From CSU Strata has branded their name recently. It was the old CSU Ventures. They are dealing with all intellectual property and property, actual property, around that is related to CSU. And they had an idea to try to figure out how they can develop an incubator for CSU researchers, that if you have an idea and a technology that you develop in your lab, how they can help you to make that a real program. So I was confident after doing so much extensive work in the field, dealing with growers, providing information, validation year after year, that yes, I have time being a faculty to deal with all of this. So I will show you a video because I will not be the best one to explain what Lab to Life is, but you will understand from this video, and then you will understand the impact that they have on my program so far. I hope it's going. And personally, sorry, why? No, now we lost it. Okay, we are sharing. Quite soon, I think. And from the my friends. So I think this is great thing for CSU, and I liked when they reached out to me. I said I applied, but they reached out to me to join the program. The main driver was its internal CSU. Sorry, I'm not going to play that again. So they provide you all the CXO, they call it. I'm learning this and not the best to explain business, but you have people that they are very senior. The whole team have raised over 250 million in their careers. So you have a combination of senior people that have a lot of experience in business, but also management, engineer, senior level schools, students, that they are actually doing the work, which is really cool. So after, like this happened last May in 2022, I joined them, and then in February we incorporated Excelsior. What is Excelsior? Is a company that provides technology for accurate sensing to inform big buy and sell decisions across the entire supply chain. So from the grower up to the retailer. We're using non-destructive scanners that we have internally pre-calibrated. The benefit is that they are non-destructive. You can scan a lot of fruit. They're pre-calibrated, accurate, efficient. You can scan big sample sizes. They work in the field, they work in the packing house, they work in the retail store. We also have know-how to do on-site optimization and customization for proprietary cultivars or whatever. So with one scan, you get a sense of when to pick with chlorophyll content and what is going to be the sweetness potential of the fruit, and also what is the actual sweetness at harvest with bricks. So after doing extensive market, you see customer discovery, you hear customer discovery. This is a big part of this. You have to interview a lot of people that are related with the industry that you are dealing with in order to see if that idea has any potential for commercialization. So through extensive market customer discovery and grower testimonials, we figure out that the best product that we can provide with success to the growers is a reporting system that the grower is using. We send the scanner for a charge, like a subscription fee, to the grower is using it, and we can provide reports about fruit maturity, consumer acceptance, sweetness, days to be picked, skin and flesh color, if there are defects. So if you can scan with your cell phone, you can see our most important from all these parameters is our harvest time indicator, that the growers are really interested because they want to inform their buyers, they want to manage their labor, they want to know when they will need most of the labor for the different blocks. And based on that work, we decided that we want to do a pilot. So we did a lot of work previously in our research farm, like in Western Colorado Research Station. Jeff was involved in the rooster program and all the rest of the work in the past, but the team from CSU Strata, they decided, okay, can you support at this level that you are a pilot study with actual growers that they are going to be paying customers? So actually, from this program, they founded 4 companies. We are the first that made some revenue. Don't expect big money, but the growers are willing to pay for this service. So we selected 5 growers, 28 piece cultivars, which were planted in around 40 blocks in Western Slope. And we were asking the growers during the summertime to track fruit quality and maturation with our sensors. And then as a product, we were delivering them our report. So a big grower that has multiple cultivars will get a summary page and also all the information that they need. How is your status of your quality, but also when you're going to be harvesting. So in here you can see 5–10% of the fruit will be ready by July 24, 25, 30 will be ready to be picked July 27, 29, and 90% by August 3 to 5. So grower comments so far, we haven't finished our post-pilot analysis, are really encouraging. Some of the growers say we couldn't believe how accurate the prediction is. So we'll see how that goes. We want to expand in other states. Of course, we want to continue with these growers because we are collecting great data and we are combining weather with Spectre in order to make these predictions. So thank you for your attention, and also I would like to thank people that have been involved in this path, part from the technology, parts from the biology, and the funding agencies that are supporting our research. Questions? Thank you.
I want to put in a plug there. So the Talbot Farms, I think, have you guys got the newsletter that I sent out yesterday? So the Come to the Table event, September 29th, Friday, 4 to 6 p.m. is going to be at Flower Garden. And Bruce Talbot is going to come, from the Talbot Farms, is going to come and bring his pitches, his alcoholic and non-alcoholic ciders to share with us, and also, share his story and experiences. In addition to Dr. Sharing our potatoes. So I want you guys to feel free to come.
So yeah, Talbots are 6th-generation peach farmers. By, I think, like 50% of peach production on the state, they manage. So we had 28 cultivars with them, like all the cultivars. They said, okay, we want to do this. They supported us very well, and we had really great collaboration this summer. But overall, support, yes. We have.
Oh,
Sorry.
let the students.
I just had a question. With all this data, are you providing it to the USDA so they can kind of modify their standards since so much is gone to waste?
Yeah, I mean, what I'm doing as an entity, I provide all the documentation that this is actually not a blem cell. You need to, like, whatever we know as researchers. So the growers are providing their claim. That includes my letter to USDA. This change USDA is going to be really hard. At that time, when they reach me out, they say they don't even allow us to give it to food bank. The sweetest fruit, they say that's declined. You cannot sell it. It's not good. Yes.
So you've partnered with growers, but I'm also curious, are you partnering with, because it looks like there was a very wide harvest range. I'm assuming that could be kind of not great, not efficient. So are you partnering with growers that are maybe trying to shorten that harvest range maybe, and to see what could do that?
So one problem we have with peaches, not with all the fruit crops, but with peaches and stone fruit, peaches, which are climacteric, the ripening is non-uniform in the canopy, and we have shown that through our work. Top fruit exposed are ripening the first, so the growers are starting from the top, and every grower has their own schedule. One decision that they want to know is like when to end it, when to start that process, and then they visit the same orchard every 3 days. If you want to focus on high quality, you need to do that. Then we are showing through our research that more uniform canopy, planar architecture is giving you more uniform ripening and more productivity per acre, but this transition takes time. So growers are aware of that. So we are partnering with them in terms of research, like as CSU, but Excelsior is just providing the information they need to know when to harvest and how the quality is.
So right now, since for the peaches, have any idea if you could move to other crops like next year?
That's it.
What kind of timeline?
So the question is, we've been doing that in peaches. Is there any applicability of this technology to other crops? Yes, it is. We have done models for apples, which are really good. And it seems that we have similar behavior with peach and apple, so we can predict harvest time of apple. If we prove that with growers, that will be huge, because apple is like 10x peach. So it's like huge crop. And then we are doing that in kiwis, because I know kiwi very, very well, so dry matter plays a very important role for kiwis. Yes. Come.
You said that USDA reject those that we have more than 50% of the ingredients. But did you calculate like only visual inspection you say it's more than 50% that we have been
Just visual inspection. So the question is about the nectarine speckling. If they're doing more in-depth analysis of the problem, they're just doing the the defect is just on the surface layers. It's not like going. There's no damage in the flesh. It's just in the skin.
Found that it is very for more than
They reject. They reject.
They'll not do any like first take a digital picture and
No.
like accuracy.
They reject. There is always in every shipment that they do, there is a USDA person that comes to check, and then the load goes. And some growers, they're not waiting at the track. They just have a cold room that is locked with a seal until they can load. So they come inspect and they can load. Yes.
Correct me if I'm wrong, but something I think I remember from Jake's presentation was you had sort of substantially different models for different cultivars.
Yeah.
In the case, does the grower have to provide the cultivar, or is it robust to any cultivar differences now?
So for 3 years, I was sleeping every night with the idea that I need to make models for every peach cultivar. I think right now we are in a position that we have global model, so that we don't need to do that anymore. We did the validation this year, for example, from one grower that has like Talbot, they have 28 cultivars. Like we didn't have models for 17 of those, so we had to do all the work to validate all this, but the models are working really good. Yeah. So we don't need to customize that much. Unfortunate for the work of Jake, but he did amazing work. We learned so much work from, so much stuff from his work. He, it was really great. But in some cases, we may need customization. So his work is still valuable. We are using it because we learn how to use the data. Yes.
So this technology takes real-time data in the field. Does it also track over a certain period of time to create models for the future, like estimated?
That is, I think, the goal of this company, Excelsior, eventually to be like a data cloud-based company, because you're just collecting digital data. Like how I was saying at the beginning, it's not that easy. It's like Google Maps. The more data you collect in the system, the good news is like we have parameters that mean something for the operation, and they are measured very well from the sensor. So we have digital data very well that we accumulate. So we combine those like in an early stage with weather, but definitely, this, I think, data people can make that, because it's like you can have information from all the world, like from what is the status for California peaches, when we're gonna be getting fruit from there, what's next. Even the same grower, for example, we have one grower, Top Fruits, it's based in Hotchkiss, very dedicated to organic people, like family farm, like husband and wife, they're running this. So they ask us, can we track the same cultivar in different blocks? We say, okay, yeah, let's do it. Because at the beginning we didn't know, like we were not sure, are we gonna serve, like, because we were doing everything manually. So the grower is scanning, they send us the data, we do our thing, and we send back the report. So that takes, so now Excelsior is trying to make that automated. That will be good for me for next summer. but we see the difference even in 10 miles in Colorado difference, orchard by orchard, same cultivar, ripening time. Even one of the growers had some very bad looking trees, and we saw that the neighbor top grower was ripening great shape and in much faster way. Then I asked him, are your trees like really in bad shape? He said, yes, because we can tell that the ripening was very behind. So, yeah.
Could you add maybe like to the actual instrument to help collect data that might be, more precise, especially for the locations like GPS, humidity readers, something like that?
That's a good point. GPS, the device has it already, but we are trying to figure out with manufacturer, because when we use too much on this tool, doesn't like it, even it's like expensive piece of equipment. But yes, you can, because the main thing for us is that the grower is willing to do this. So I think we find a spot that the grower is very interested, and we are collecting the data in a complete emotional disconnect of the grower with the data. We just ask the grower to do a number of scans. That's it. You don't need to think anything. We will provide the report. And this seems to be really good for the grower. They just get the report.
Okay, we have time for one more question.
So what's the correlation of sugar level with consumer dissatisfaction parameters? If yes, then in specific sugar like sucrose, fructose, or anything?
We are not doing, so the question is about if consumers like particular sugars. There is no much detail analysis on that, like information. Always we say we need to do these kind of things, but it's really hard to track this because there's multiple components involved. Like you need to select fruit of equal maturity. Then is the texture the same in order to understand consumer behavior. Sorbitol is less sweet. Sucrose is the main, and then fructose, glucose also contribute. But yeah, we have seen that consumer like high sugar content, high bricks, and then dry matter is in kiwi, for example. Dry matter is the percentage of dry matter you measure. You remove 3%. It is the bricks content at harvest, at consumption, when all the starch will be hydrolyzed. In pits, depending on the cultivar, it's the level of dry matter. If you remove 1.5 to 2.3%, it's the sugar content, the bricks content at consumption, which is really cool that you can predict